All right, here we go. So this is a video that's going to help out with some of those discriminant questions. Here we are asked to find the value of k. So k is just a parameter. We can see it in a couple of these equations. So that the line y equals kx minus 3 is tangent to y equals kx squared plus 2x plus 1. Now remember, tangent implies that this line and this parabola, they only touch once. So it'd be something like a line and a parabola, only touching at one specific point. So there's going to be a value of k that makes this line and this parabola intersect like that. So let's take a look at how to do this. Well, this is solving a system of equations. So we're essentially looking for a point where this and this are equal to one another. So that's actually going to be our very first step. So our very first step is going to be to set the two equal. So that was kx minus 3 is equal to kx squared plus 2x plus 1. So here we're assuming that an intersection is going to occur, and we're going to go ahead and find it. Now, when we're solving a system of equations, all we have to do is bring everything to one side. So this will become 0 is equal to kx squared. We'll move terms over, plus 2x. Now this term contains an x, and this term contains an x, so I'll write them beside each other. So this will be minus kx. Then we have plus 1, plus 3 is plus 4. So I now have a quadratic, but you're saying, wait, there's 4 terms. But these two terms are actually like, because they both contain a degree of 1. This has a degree of 1, this has a degree of 1. So this will be 0 equals kx squared. Now what's 2x minus kx? Well, that's 2 minus kx. And that looks an awful lot like common factoring as well. If you just common factor out an x, you're left with 2 minus k from both those terms, plus 4. Now, why was that important? Well, that was particularly important because this is our value of a. This is our value of b. This is our value of c. And those are going to be our values that we'll use when we try to find whether or not we can find a value of k that makes this thing tangent. Now, for this to be tangent, that must mean that the discriminant has to be equal to 0. So 0 is equal to our discriminant, which is b squared minus 4ac. Now, often with questions like this, you run into a quadratic needing another quadratic to be solved. And I know that this could be a quadratic because this b term is squared. Now you'll notice I'm not doing the entire quadratic formula here, and that's just because I know for tangent, I must set my discriminant equal to 0. So I'll substitute in my values. B squared is 2 minus k squared minus 4 times a, which is k, times c, which is 4. And that's all going to be equal to 0. I'll expand. And you should be pretty quick at expanding binomials by this point. So 4 minus 4k plus k squared. And then expanding this is minus 16k. So once again, you see I have that other quadratic I was talking about. I'll just combine my like terms and write it in the order that I like. I prefer my quadratics to have my squared term first, and then my term containing just a linear term second, and then my constant term last. So this is a simple trinomial, k squared minus 20k plus 4. It's also a simple trinomial that doesn't factor. You can do a quick check, but trust me, it doesn't factor. So I'm going to have to use the quadratic formula yet again, although this time I'll use the whole one, because I know that this is going to have roots. K squared minus 20k plus 4 just feels like it's going to have a discriminant that's greater than 0. So I'll assume that I'm going to have 2 roots. It's a reasonable assumption because this value is quite large. So my value of k is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is getting a bit repetitive, but I hope that what you can see this time is now my value of a is equal to 1. My value of b is equal to negative 20. And my value of c is equal to 4. Yes, I have different values of a, b, and c from here because I'm now at a different point in the question. And I'm soon going to run out of paper, but we'll keep going. So negative b is negative 20, so that's positive 20, plus or minus the square root of 20 squared. Now I'm going to do a weird thing to 20. I'm going to write it as 4 times 5 squared. You'll see why in a second. Minus 4 times a, which is 1, times c, which is 4. And this is all over 2a, which is just 2 times 1, or 2. So I'll continue simplifying because I don't have access to a calculator right now. So 20 plus or minus the square root of, now some of you might expand this whole thing and then try to reduce this radical. Now this is 4 times 5 squared. So it's 4 squared times 5 squared, because this square can distribute into each of these terms. So I'm going to common factor out a 4 squared from this first term and a 4 squared from this second term, where I have 4 times 4. So this will be 4 squared times, now from the first one, I have 5 squared left, and from the second one, I've got 1 left. And this will all be over 2 still. Now that just makes reducing my radical easier, because I can take the square root of these terms independently. The square root of 4 squared is 4. So this will become 20 plus or minus 4 root. Now 5 squared minus 1 is 25 minus 1, or 24, over 2. Now I'm not quite finished because 24 still reduces as a radical. We can divide another 4 out of it, meaning this will become 20 plus or minus 4 root 4 times 6 over 2. And I've quickly run out of paper, so we'll tear this off and keep writing. So I've just taken 24 and broken it into 4 times 6. So this will be equal to 20 plus or minus, now I'll take the square root of 4 when I remove it, so that's 2. So that's 8 root 6 over 2. And now I can reduce my fraction. 20 over 2 and 8 over 2. There's a 2 common to each of these terms. So this will become 10 plus or minus 4 root 6. So my solution is k is equal to 10 plus 4 root 6. And you say, well, Mr. G, how come you only have one solution? Well, I only have one solution because the question asked me for find the value of k. But of course, the question was wrong. It should have said find the values. And often when you see values, that's a very good hint that you're going to be dealing with a quadratic that's going to yield 2 roots at the end. That values and values, because there's actually 2 values. There's this, or there's this. Now, I would say that that's a fairly challenging question, in that there were multiple steps that we had to go through. There were multiple assumptions that we had to make as we went. Now, I showed a lot more steps than I think I suppose I needed, but I still got down to the final answer. Now, for just a quick look at what this might look like on Desmos, I don't know if this will show it. I have my 2 things graphed. I have kx minus 3 and kx squared plus 2x plus 1. You can see that the graph of the quadratic and the graph of the line are tangent. They're tangent when I have 10 minus 4 root 6. They're also tangent when I have k equals 10 plus 4 root 6. I'll just have to zoom out, change my zoom, and you can see that the red line doesn't ever cross the green line. I think I could zoom in a little bit closer to show it, but it is going to be a very, very tight tangent, so it'll be difficult to see. And so those are your two possible values, 10 plus 4 root 6 and 10 minus 4 root 6. Hope that helped with your discriminant questions.